Let's say you ask to differentiate this function y equals 1 over x squared from first principle. Now, comparing it to what we have using the formula method, we can say y is also equal to x raised to the power of minus 2 from indices, and dy dx will give us minus 2x raised to the power of minus 2, then minus 1. And this gives us minus 2x raised to the power of minus 3, or minus 2 all over x raised to the power of 3. Remember indices, from law of indices we have that x raised to the power of minus a is equal to 1 over x raised to the power of the positive a. So this simplifies to minus 2 times 1 over x raised to the power of 3, which then gives us minus 2 over x raised to the power 3 as our final answer. This is using the formula method. But it was specified that we have to use the first principle. How do we go about it? Let us have this over here. The function is 1 over x squared. Remember, the first step I told you is you're going to take an infinitesimal increase in both x and y and rephrase the function this way. Y plus the y equals 1 over x plus the x raised to the power of 2. Now, if you do this, deciding to take y to the other side, if you take y to the other side, or you simply subtract y from both sides. If you do that, we have y plus dy minus y is equal to 1 over x plus the x all squared, then minus y. Remember, from this point here, we have that y equals 1 over x squared. So if you substitute the value of y into the equation over here, we have that y plus dy minus y is equal to 1 over x plus the x all squared minus 1 over x squared. Now remember that y can cancel out. This cancels out. We have dy is equal to 1 over x plus the x all squared minus 1 over x squared. Let me confirm if it is actually correct. Alright. Now the next thing to do is to decide to take the LCM. If I take the lowest common multiple of both sides, I have this to be x raised to the power of 2 times x plus the x all squared. So if I look for the LCM and compute arithmetically, I'll have this will cancel this, and I'll be left with x squared minus this will cancel this over here. This will cancel this. I'll be left with x plus the x all squared times 1, which will give us x plus the x all squared. But remember, this is in the bracket so as to differentiate it from this sign over here. And if I do the computation, I would have that the y will be equal to x squared minus x plus the x all squared all over x squared into x plus the x all squared. If I go over to the next step, which is actually to open up the bracket, I would have the y equals x squared minus x plus the x all squared is the same as saying x plus the x times x plus the x all over x squared into x plus the x all squared. Now this takes us to the next step, which is the y rather equals x squared minus x squared, then minus x squared plus 2x the x plus the x all squared all over x squared into x plus the x all squared. Now if you open the bracket, we have that the y is equal to x squared minus 2x dx minus times plus is minus the x all squared, then divided by x squared into x plus the x all squared. And if you do this, you would have that x squared will cancel out. We have the y is equal to minus 2x dx minus the x all squared all over x squared minus x squared into bracket x plus the x all squared. And the next step is to divide through by the x so as to have something like the y over the x. Remember, our aim or our target is to find the y over the x. So dividing through by the x will give us this, which will give us minus 2x dx minus the x all squared all over x into x plus the x squared, then divided by the x. From the reciprocal law, if I have x over a all over b, this is still the same thing as saying x over a divided by b over 1. Of course, it is x over a times 1 over b. So if I apply this same rule that I have over here, I will have that the y dx will be equal to minus 2 dx minus 2x dx minus 2x dx minus the x all squared all over x squared into x plus the x all squared, then times 1 over the x from reciprocal law. And if I decide to factorize this term over here, if I factorize this, I would have that the y over the x is equal to the x into minus 2x, then minus the x all over x squared into x plus the x all squared times 1 over the x. Of course, the x can cancel out, and I'll be left with this. This is still infinitesimal change. This is the y over the x, and this also is the y over the x, because we've not yet taken the limit of both sides. So this gives us the y over the x is equal to minus 2x minus the x all over x squared x plus the x all squared, then times 1. Now, Avon says that the next thing to do is to take the limit of both sides. If we take the limit of both sides, I would have lim dy over the x as the x tends to 0, which is give us the y over the x. And remember, I said as the x tends to 0, any other term that has the x on the right hand side will tend to 0 as well. So the limit of the y over the x will give us the y over the x, which will be equal to, we have minus 2x minus the x all over x squared into x plus the x all squared. Expanding the denominator, if I expand the denominator, I would have x squared into x plus the x all squared. So this gives us x squared into x plus x squared plus 2x dx, okay, then plus the x all squared. So if I open the bracket, I have x raised to the power 4 plus 2x raised to the power 3 the x plus x squared the x all squared. So if you now put this inside this our equation, we have the y over the x is equal to 2x, okay, minus 2x minus the x all over x raised to the power of 4 minus a plus 2x raised to the power 3 dx, then plus x squared dx all squared. And I said that as the limit of the y over the x is taken as the x tends to 0, that any other value with the x or having the x term will tend to 0. That means this will tend to 0, this will tend to 0, and this will tend to 0. And if I simplify further, I have the y over the x is equal to minus 2x all over x raised to the power of 4. And of course, x will cancel out. This will remain 3. I'll now have the y over the x is equal to minus 2 over x raised to the power of 3. Now let us go to the first slide where we used the normal formula method to solve. Our answer was minus 2 over x raised to the power of 3. So let us compare this answer over here to what we have now using the first principle to check if they will give us the same answer. So let us check. Of course, we have the same answer. So therefore, the differential of the function y is equal to 1 over x squared is equal to minus 2 over x raised to the power of 3. I will confirm that using both the formula method and the first principle method. And I'm sure that this has proven beyond reasonable doubt that whichever method you decide to use will still give you the same answer. This is where we'll end it on this note in the differentiation using the first principle. So in our next class, we'll solve many more problems on differentiation using first principle. So see you there.